Good evening, students. Today I am going to explain about Hoffman degradation reaction. In this reaction, it will come in amines. So any amide, when you treat it with bromine and 4 moles of KOH, amide, this CO will be removed and RNH2, primary amine, will be formed. These two bromines combined with the 2 potassium, KBr will be formed, and this CO and one more O, CO3, and 2 potassium, K2CO3. So 2 OH combined with the 2 hydrogens, 2 water molecule will be formed. So this is it. So to understand to remember for this reaction, we can see the mechanism. So amide, RCONH2, when you treat it with bromine, it will abstract first this base will abstract H plus ions. H plus ion is abstracted. Now this bromine is attached here, one bromine. Next, and again if you treat it with the base, again base we are adding simultaneously, base and bromine we are adding. Base will abstract this another hydrogen. So this H plus only removed. So this pi electron will be shifted towards like this. Here will be minus. So to stabilize this minus charge, this R will be rearranged to this. Okay. When R is removing, here will be C will be plus. This N is minus. So N is connected with R, but N minus and C plus will become double bond. So it is called alkyl isocyanate. This is called alkyl isocyanate. If you do hydrolysis, so in hydrolysis, here will be minus, here will be plus. So H plus will be added here, OH minus will be added here. So this CO2 will be removed, H plus will be shifted, hydrate shift will be from here to here, bond breaking will be happens like this. So here bond breaking is happens, here will be C plus N minus H plus will be added, it will become amine. So this is the mechanism, students. This next, primary amines also can prepare from Gabriel phthalimide synthesis. So Gabriel phthalimide means benzene ring C double bond O NH. This is called amide. Amide, 2 carbonyl group is connected to this NH. This is called phthalimide. Okay, this is phthalimide. When you first, what are the reagents can be added? First strong base, next alkyl halide, and again strong base. First, when we add this strong base, K plus OH minus, Na minus H plus. This OH minus H plus will be removed as a water. So this K will be added here. Next, alkyl halide, halogen will be minus, alkyl will be plus. Again, this K plus N minus. K plus halogen will be removed as a Kx. Now R is attached. Now if you treat it with 2 moles of NaOH, aqueous NaOH, so here is here bond cleavage will be happens here. Bond cleavage will be happens. So this OH will be attached here. So OH will be attached here. So one more OH also attached here. Now this base Na plus will replaces this H plus. This H plus will be added to this Rn and making as a primary amine. So this is the mechanism. Next, haloform reaction. Haloform reaction means condition is, so methyl ketone or acetaldehyde. In acetaldehyde also CH3CO is there. Ethanol also, if you treat it with iodine and base, it will be oxidized to this acetaldehyde. And secondary methyl carbonyls. So secondary alcohols. All this, any one of these, when treated with halogens and base, strong base, it will give haloforms. See RCOCH3, that is ketone. When you treat it with 4 moles of base NaOH, and halogens. Okay, here, so three halogens. So here will be this CH3, three hydrogens will be taken, three hydrogens will be removed. So three chlorines will be added. Okay, so what will happens? This entirely this CH3 will be removed. In CH3, in the place of three hydrogens, two hydrogens. Okay, so the mechanism will let us discuss. So RCO, carboxylic acid will be formed and chloroform is formed, and NaOH will be become NaX and water. Next, so this also, this acetone and ethyl alcohol, if you treated with bleaching powder and chlorine and alkali also we can prepare this chloroform. This acetone, when treated with chlorine, it will form trichloroacetone. Then again, if you treat it with calcium hydroxide, you will get chloroform. Next, haloform reaction mechanism. RCO ketone group and CH3 must be there. If you treat it with base, it will abstract this hydrogen. It will form a C minus. It is enolate anion. C minus, if it is shifted here, pi electrons will be shifted here. So O minus, double bond C, CH. Now halogens, one will be plus, one will be minus. So here already electron density is more, so that the halogen plus will be attached here. Halogen plus will be attached here. That and the Br X minus will be removed. So here is alpha halo methyl ketone. This is alpha halo methyl ketone. Again, if you treat it with base, one more hydrogen also will be removed. C minus will be formed. Again, if you treat it with halogens and another X plus will be added here. So 2HX, two halogens will be added. One more, only one hydrogen. Again, if you treat it with base, that that hydrogen also will be abstracted by base. Now minus. Again, if you treat it with halogens, that X plus will be added here. Now three halogens. Now these three halogens and with ketone, that is we can call trihaloketones. If you treat it with base, this base will attack on this carbonyl carbon. Now here is this carbon is having negative charge, and negative charge, it is highly, it is unstable. So this bond will be broken, and what will happen? So this hydrogen will be shifted, proton. So here is a bond breakage will be happens. C minus, three halogens. So proton exchange will be from this here to here, it will be happens. So RCO minus and haloform. If X is equal to chlorine, chloroform. X is equal to bromine, then it is called bromoform. If X is equal to iodine, iodoform. But fluoroform is not, cannot be prepared. Okay, thank you students.